This is a 22 operation recipe which decodes a 3-stage malware which goes from what we have right here over into these decoded C2s that we can see in the output over here. So this malware initially starts with this script here, which takes a bunch of decimal characters, subtracts the value and decodes it. That unravels this second stage, which uses a combination of base 64 and AES encoding. And then once the AES encryption is completed, it unravels a third stage, which has some encoded C2 addresses hidden inside of these decimal values. So I'm going to go ahead and take the original script and I'm going to show you how I do that in CyberChef. So I'm going to open up a new recipe here, and the key thing we want to do is we want to extract this giant blob of decimal characters, and we also need to extract a value which is subtracted from them, this 787 here. So the very first thing I want to do is I want to grab that 787 and I want to store that inside of a register. Now this is going to require a little bit of regex, so I'm going to capture this by specifying a sequence of characters followed by a space followed by an equals followed by another space, and then I want to capture any decimal value that happens after that. Now I can do that with this register here, which we can see in this R0 has successfully captured the 787. What I want to do now is capture these large decimal values, and I'm actually going to do that with a regular expression because now that I've captured the initial register, I want to ignore everything else. So I'm going to do that by saying I want to capture these values which are inside two round parentheses, and I want to capture any digits followed by commas, and I want a sequence of 1000 or more. If I put that into CyberChef and I go to list matches, I can see that I've successfully captured just this decimal value. I don't want the brackets at the beginning and end, so I'm going to add a capture group inside of the initial brackets, and I'm going to change this output to list capture groups. And now we just have the decimal content, just this array from the initial script. I've captured those decimals. What I want to do is subtract this value from each of them, and then I want to decode it using a from decimal. So I'm going to use a fork operation, and I want to split on the commas, and I want to merge with a new line, and that gives me this here. Now, normally we could use the sub operation, but to act on all of these values independently, but sub does not play nice with numbers that are greater than 255, which I think is the exact reason why this number is so large. So what I actually need to do instead is add the number 787 to each line and then apply a subtract operation. So I'm going to cancel that. And what I'm going to do is I want to grab every single line and replace it with itself. And then I want to add this R0 register. And I want to turn off global match because it's captured 2 for each line. And now we can see that every single decimal value now is followed by 787, which has come from this R0, which if we go back to the top, we can see it was captured in our initial register. Now I can apply a subtract operation specifying a space as a delimiter because we've put a space in between our values. And now we can see a list of much more reasonable looking numbers. I want to apply a from decimal. And now that we can see that we have plain text, although it's split between new lines. So what I want to do is go back to this fork operation, and I want to change the merge delimiter to a space just to get a better look. That looks much better. So now I'm going to change that merge delimiter to nothing. And now we have the second stage script, which is exactly the same as what we have here from some previous reverse engineering. In this second script, we have a base 64 encoded blob, which is actually double encoded with AES. And from my previous analysis, I know that the AES key is this value right here. And I know that the initialization vector, which is essentially just the second piece of the key, is the first 16 bytes of this base 64. We can see kind of here, the IV comes from this variable, which is coming from the first, 16 bytes. So first I need to extract the key. So I'm going to do that with another register. And before I do that, I'm going to use a merge operation. And that will essentially undo the fork. The key is stored right here inside of this base 64 text. And we can see that it's exactly 44 characters. So I'm going to apply a register. And I'm going to use the regular expression for base 64. And I'm going to specify exactly 44 characters. And that hasn't worked, so what I'm actually going to do is specify that I want single quotes around the key because it's actually grabbing this base 64 up here and not this one, which is the one that I want. So now if I take a look at that, I can see this DVDQ ending with an equal sign, and jumping back to the script, I can see that this is the AES key. And again, we know that because we can highlight the variable and we can see that it's assigned to the key portion of the AES. So now that I've extracted the key, I'm going to apply another regular expression, and I'm going to use that to extract out this base 64 up here because this is the primary piece that I'm interested in. So again, I'm going to use the regular expression for base 64. And this time I'm going to say I want 100 or more characters. Now this should work because I think there is only actually two base 64 blobs inside the initial code, and we know from before that this one is 44 characters, so specifying 100 or more should get it. And if we leave highlight matches enabled, we can see that that's matching correctly. Now what I can do is change this highlight matches to list matches, and now we have just the main base 64 blob. Now I want to apply from base 64, and now we have the AES encrypted data. Now again, before we go ahead, we need to actually extract out the initialization vector, which is the first 16 bytes. So I'm going to do that by applying a register again, and I'm just going to say grab the first 16 characters that you see. Now if we let CyberChef run for a few seconds, we can see that R2 has captured these 16 null bytes, so that looks good. Now that we've captured that, we actually want to remove them because they're not part of the data. So I'm going to say drop bytes 16, and now we have just the AES data. So now what we can do is we can say AES Decrypt, and now we can begin applying the registers that we extracted before. So the very first register we captured was the key, which was in base 64 format, so I want to apply base 64, and I actually forgot what the register number was, so that was R1, so we can just specify R1 here. The initialization vector is stored inside of R2, so we can specify that here. We captured the IV after any encoding, so we can change this to UTF-8, and the mode I believe was ECB. If we go back to the script, you can see ECB mode here, and the data in its current format is raw, so change that. And now we have the data after it's been decrypted with AES. Now it still looks a little bit like junk, and the reason for that is that it's actually GZIP compressed as well, and if we didn't know that, we could find that out by using a 2hex operation and noticing this 1F8B byte here, which is the magic bytes for GZIP. So now we can go back to our encrypted blob and we can apply a gunzip operation, and that will reverse the GZIP compression. Now we do get an error for invalid file signature, and the reason for that is that there are some random null bytes at the end of which is over here. I'm not sure why they're there. Potentially CyberChef handles AES different to PowerShell, so I'm going to use a find and replace, and what I want to do is capture any trailing null bytes at the end of my input. So we can say null byte, one or more with a plus sign, and then this $sign says that it has to happen at the end. So I can do a find and replace here, and now the null bytes are removed from the end of the data, and we can apply our gunzip operation. And now we have a stage 3 script. And if we copy this and jump into a text editor, we can see the primary form of obfuscation is very similar to the first technique, except this time it's decoded by this WVA function, which is defined over here, and this is actually subtracting the number 4274. We can see the subtract operation here. What I need to do is actually extract out that number again, and I can see that it's stored in this $SHY equals 4274. To grab that out, I'm going to have to use another register, and I'm going to say any $, followed by one or more characters, followed by an equal sign, followed by any number of digits, and also followed by a semicolon. I don't want this entire thing, I just want the number at the end, so I'm going to move the capture group to just the decimal values. If I hit run, I can see that the value 4274 is stored inside of the R3 register. I can use another regular expression to capture out each of these lines of decimal code, and there is 1, 2, 3, 4 in total. So I've opened up a regular expression, and I'm going to say any round brackets that contain only numbers or commas, and I want to say 50 or more. Now if I just leave this as a regular expression with highlight matches, I can see that each of these has been successfully captured, which means our regex is working. And what I can do now is change this to a list matches. And this leaves us with just the decimal values, but it has included these brackets, which I don't really want. So I'm going to add another capture group inside of the original round brackets, and I'm going to change this to list capture groups. Now we just have the 4 arrays of decimal characters that we could see over here. I want to decode each of these independently, so what I'm going to do is apply a fork operation with the default delimiter of newline, and that will act on each of these arrays independently. Now, within each array, I actually want to act on each value independently, so I'm going to specify a second fork with a comma delimiter. And now this will display all of our values like this. Now I want to do the same technique as before, and I want to capture each individual line and replace it with the same value followed by what was in our most recent register, which is this R3 containing 4274. So I can go ahead and hit enter on that. And we can see that 4274 has been added to each line. It's actually been added twice, so I want to turn off this global match. And now that looks much better. What I can do now is apply a subtract operation and specify that the delimiter is a space because we have space in between each of these. And now we have just the original decimal values, so we can apply a from decimal. And now we can see this net.web client and https.something, which looks like our C2, or at least the URL where our next stage is being downloaded from. Each of these is on its own new line, which I don't want. So I'm going to change the most recent fork delimiter to an empty space. And now we have a decoded net.web client and 2 decoded URLs, which are likely where the next stage of the malware is being downloaded from. And we have a recipe which is working to decode 3 stages of malware, which is around 22 operations. Now, one of these is actually missing, so I can change this from 50 or more to maybe 30 or more. Yeah, and now we have the 4 decoded values. So one of these was potentially too short for our regex, which might have been this one over here.